In our last video for Mod 6, we are talking about double angle identities and half angle identities. We're going to start with the double angle identities. The double angle identity for sine says that if you have the sine of 2 theta, that equals 2 times the sine of theta cosine theta. For cosine of 2 theta, you could use cosine squared of theta minus sine squared of theta, or by rewriting using Pythagorean identities, you could get the two alternate versions of 1 minus 2 sine squared of theta, or 2 cosine squared theta minus 1. The tangent of 2 theta equals 2 times the tangent of theta over 1 minus tangent squared of theta. For practice in using our double angle identities, we are going to look at example 7, where we are told that the cosine of theta equals 3/5, and that the sine of theta is less than 0. And then we are asked to find sine, cosine, and tangent of 2 theta. When you have a problem like this, the first thing that you must look at is the given information. We are told about the cosine, and we are told that it is positive 3/5. We have to think about, where is cosine positive? Cosine is positive in quadrant 1 and quadrant 4. We are further told that the sine is less than 0, which means that the sine is negative. So we have to think about, where is the sine negative? That is in quadrant 3 and quadrant 4. Where do these things both happen? Quadrant 4 is where they both happen. So we are going to set up a figure with angle theta in quadrant 4. And the cosine x over r has to be 3/5. Well, we've used this a lot now, and we know that if we have 3 on one leg, the other leg has to be 4 if the hypotenuse is 5. But remember, when you are in quadrant 4, that your y value must be negative. Now that we have our figure set up, we are going to use our formulas. The sine of 2 theta equals 2 sine of theta cosine theta. So we're going to keep the 2 on the front. Now we're going to look at this angle theta that we just created. The sine of this angle theta would be negative 4/5. The cosine of this angle theta is 3/5. If we multiply 2 times negative 4/5 times 3/5, we get negative 24 over 25. For the cosine of 2 theta. We were told about the cosine of theta, so I'm going to use that version of the formula, which is 2 cosine squared theta minus 1. So we would have 2, our cosine, we were told, was 3/5. We're going to square that, subtract 1. So we're going to have 2 times 9 over 25 minus 1. This will give us 18 over 25 minus 25 over 25, which gives us negative 7 over 25. Our last item is to do the tangent of 2 theta. The formula for tangent is 2 times the tangent of theta over 1 minus tangent squared of theta. So our numerator will be 2 times the tangent of our theta is going to be -4/3 over 1 minus -4/3 that we are squaring. So our numerator becomes -8/3. On our denominator, we will have 1 minus 16/9. So we're going to think of that as being -8/3 over 9/9 minus 16/9. So we are now going to have -8/3 over -7/9. Rules for fractions say that you multiply by the reciprocal of the denominator. So we are going to take -8/3 times -9/7. You would get positive 72/21. Simplify that, you're going to get 24/7. On example 8, you are asked to simplify the expression using a double angle identity. And then on problem A, we are given 1 minus 2 sine squared of pi/9. What you need to recognize on this one is that this is one of the versions of the cosine of 2 theta. So we are going to rewrite this then as the cosine of 2 times the theta, which is what comes after the function. In this case, it's pi/9. Now do your multiplication there, and you get the cosine of 2 pi/9, and that's all you need to do with this. You are done with that problem. On example B, we are given the expression 2 times the tangent of 50 degrees over 1 minus tangent squared of 50 degrees. As soon as I see tangent in this expression, I know that this one is the tangent of 2 theta. Our theta is whatever the argument of tangent is. So this is going to be the tangent of 2 times the 50 degrees, which is going to give us the tangent of 100 degrees. That's all you need to do. You are done. Stop there. The last item for this mod is half angle identities. The sine of theta divided by 2 equals plus or minus the square root of 1 minus the cosine of theta over 2. The cosine of theta over 2 is plus or minus 1 plus the cosine over 2. And then to get the tangent, if you do the sine over the cosine, you get the square root of 1 minus the cosine over 1 plus the cosine. By rationalizing the numerator, you get the second version, which is the sine of theta over 1 plus cosine of theta. By rationalizing the denominator of the tangent, you get 1 minus cosine theta over sine theta. Any of the versions of the tangent formula are fine. You will get the same answer. Technically, they will not always look the same because if you use the first version, you will have square roots, and if you use the other two, you will not. Now that we have been given our half-angle identities, we're going to use them to find values for our given functions. On A, we have the tangent of 7 pi over 8. The first thing you have to do is decide, should this be positive or should this be negative? Think about 7 pi over 8. 7 pi over 8 is in quadrant 4. So tangent in quadrant 4 is negative. So we do know that we're going to have to put the negative on the front. The plus or minus on the front means you have to think about what quadrant are you in? Should it be positive or should it be negative? Now, we are going to rewrite what we were given. It's the tangent of what? Half of what? 7 pi over 8 is half of 7 pi over 4. Think about if you multiplied those two fractions, you would get 7 pi over 8. So now when we go to the formula, the only thing we use in the formula is the 7 pi over 4 part of it. I am going to use the first version without the radical, the sine theta over 1 plus cosine of theta. So our problem will become negative. Now we're going to drop the tangent and put in the numerator function, which was sine. Use only the angle that you said was the half, 7 pi over 4. Put that over 1 plus the cosine of 7 pi over 4. So we've got a negative sign out front, and then the sine of 7 pi over 4 is negative square root of 2 over 2. That goes over 1 plus the cosine of 7 pi over 4 is positive square root of 2 over 2. Well, the negative of a negative is going to give us positive square root of 2 over 2. In our denominator, I'm going to rewrite the 1 as 2 over 2 plus the square root of 2 over 2. So now I have the square root of 2 over 2 over 2 plus the square root of 2 over 2. Flip and multiply by the denominator, so we have the square root of 2 over 2 times 2 over 2 plus the square root of 2. 2 over 2 equals 1. We are left with then the square root of 2 over 2 plus the square root of 2. You may leave your answers in this form. You do not need to do anything to change that. Do not put it in your calculator. Leave it alone. On B, we are asked to find the cosine of 165 degrees. First of all, again, think about what quadrant. 165 is in quadrant 2. In quadrant 2, cosine is negative. So we are going to be negative. The other thing we have to think about is how are we going to rewrite that 165 degrees? So we are going to think of cosine of 165 as being half of what? What do you have to take half of in order to get 165 degrees? You have to take half of 330. So now when we are putting things into our formula, 330 is the angle measure that we are going to use. The cosine formula for cosine of theta over 2, you are going to do plus or minus the square root of 1 plus cosine of theta over 2, since it's off screen. If you think about it, it's theta over 2. So here's our theta, here's our 2. When you go into the formula, the only part you put in is the theta. So we said that this needs to be negative, and then we're going to have the square root. We're going to do 1 plus the cosine of what we said theta is, 330 degrees, divided by 2. So that's going to give us negative the square root of 1 plus the cosine of 330 degrees is the square root of 3 over 2. And all that is over a 2. So we have negative square root. I'm going to rewrite 1 as 2 over 2 plus the square root of 3 over 2, and all that's over a 2. So now our numerator can be written as 1 fraction 2 plus the square root of 3 over 2, and all that's over a 2. And all that is within your square root symbol. Because we have a complex fraction, we are going to multiply by the reciprocal of the bottom. So it will be 2 plus the square root of 3 over 2 times the reciprocal of 2 is 1/2. So we now have negative square root 2 plus the square root of 3 over 4. Rules for square roots say you can split it into the square root of the numerator and the square root of the denominator. We cannot do anything with that square root of the numerator, so it's going to stay the square root of 2 plus the square root of 3. But the square root of 4 equals 2. Now that is your final answer. Our last example is the sine of 15 degrees. 15 degrees is in quadrant 1. So it needs to be positive. Let's rewrite 15 degrees. It's half of what? Half of 30. So our theta is 30. The formula for sine, just so you have it, is the square root of 1 minus cosine theta over 2. We already know this is going to be positive, so I didn't put the plus or minus on the front. So for our problem, this is going to be the square root of 1 minus the cosine of 30 over 2. So, square root of 1 minus, replace cosine of 30 with what it's equal to, the square root of 3 over 2. And all that goes over 2. Rewrite your 1, just like we did on the last problem. We will have the square root of 2 over 2 minus square root of 3 over 2. All of that is over 2. So we will now have, as our numerator, 2 minus the square root of 3 over a 2. We're writing it as 1 fraction, and all that is over a 2. Multiply by the reciprocal of the bottom. You will have 2 minus the square root of 3 over 2 times 1/2, all inside your square root. So now we have the square root of 2 minus the square root of 3 over 4. Split that up like we did on the last problem. You will have the square root of 2 minus the square root of 3 over 2. That is your final answer.